Module, we're going to talk about modules, Python modules. So modules are a means of organizing functions, classes, constants, etc. that intrinsically belong together. So they allow the core language to remain small while simultaneously facilitating language growth and expansion. We've already used several built-in modules, including the math module, random module, and string module. So writing your own modules allows you to collect and reuse similar code. For example, in my own work, I've created an image analysis package, a statistical analysis package, a text processing package. So that allows me to group them and share them in a collective way. It also avoids colliding names. I may have a strings package, but because it's a sub-package of my text processing, I can have it won't collide with the strings module or package in the base language. So what is a module? So a module is simply a Python file. And you can gain access to that module with the statement import and then the name of my module. And this simply requires that Python file be somewhere in the Python path, the list of directories that Python is looking for modules in. So when I do import my module, it loads the entire module into the current program. And this happens only once because this is a computationally expensive step for Python to search everything and find it. And we'll talk about if you make changes to your module, how to get those changes recognized into your Python shell. Alternatively, I can import individual elements from a module. So I can use the syntax from my module import my function. And this only loads the function, my function, from the module into my current program. So I can import and I can rename a module, and this is quite common, and you've probably seen me do this with NumPy. So import my module as MM, which is like an alias or a synonym. I can also load everything from a module with a from my module import star. This is not generally a recommended step because A, it makes it hard for someone reading your code to be aware of where the particular definitions come from, and B, also leads to a greater probability of name collisions. So here's just some example where I'm importing the math module and I'm running a function from it. Similarly, I'm importing the OS module, where from the OS module, I'm importing a specific function, get current working directory. Importing string as string, renaming it. Importing everything from the random function, and then calling a particular function that got imported. Okay, and as I mentioned, importing is a computationally expensive function, so it's only performed once. If you have made changes to a module and want to have access to those changes, then you do the reload function. So you reload is a function that takes as an argument a module name. Okay. So just like functions are objects, modules are also objects. So when an import statement is executed, Python creates a module object. And the object has a variety of attributes. It has the name of the imported module and other attributes. So let's go through some of these. So it has the name double underscore name double underscore. And the value that's assigned to the name will either be double underscore main double underscore if the module is being used as a script or a program, or it will be the double underscore and then the module name that was imported. That will be the name of the module. There's also a file that tells where the module was defined, where Python found it. A doc variable that has the doc string that's defined for the module. And you can, just like we have done with other objects, you can explore what the attributes of a module object are through the dir function or .tab exploration. Okay, packages allow you to organize modules into related collections. Oops, let's see. Modules as objects, okay. Okay, I skipped ahead there. Okay, so having imported math, I'm going to print these attributes. So file, this is where it found it on my Python path. The name of the module is math, and here's the docstring. This module is always available. It provides access to the mathematical functions defined by the C standard. Okay. Again, showing that exploring the math module with the dir function. See if I can get my help to pop up here. I can do help on a specific function. Okay, so how do we create our own modules? All you need to do is create a Python file. The module can contain any Python object, and I've created an example here called mdcrc.py. And I can bring that up here. So I've got a docstring at the top of the file. This will be the docstring for the module. I import the random module. I define some constant. I have a variable that's a list of the students in the class, which now that I think about it, since we're past the add drop date, I should have made it a tuple instead of a list, and the teachers. Then I have some just different functions. So that's my mdcrc module. So like I said, I print it out. It tells me where I found it. I get the help. So it gives me the docstring that I had for the module. But when I do the help, you see I'm also getting these descriptions of the functions with their docstrings, and it's telling me the functions I have and then the data that I have. Okay, and as you saw, I had imported random into my mdcrc module, so I can now actually access random through mdcrc, even though I haven't explicitly imported random into my own program space. So I can, oops, I guess I haven't actually evaluated this. We're just running through the slides. So, oops. Okay, so let's talk about creating packages. I don't know why, there's my package heading. So packages allow you to organize modules into related collections. And so essentially, from kind of a creating modules point of view, a package is a directory. The directory can contain files, which are modules, and subdirectories, and those subdirectories can then act as subpackages. But in order for that directory to be viewed as a package by Python, the directory must contain a double_init_.py file. So let's talk about what goes into that file. The file can be empty, I mean absolutely empty. You can just create it and it can have 0 bytes, but it has to exist. But more usefully, it can contain arbitrary Python code. So common things that you would put into a double_init file would be a docstring for the package, a special variable called all, which is a list of the specific modules that you want imported when you do a from package import star statement. You might provide version information about the package and code that you want executed depending on what platform you're running on. You also can put explicit imports of the modules in the in the package that you would like to be imported when the package itself is imported. Okay, so I've created an example module named Chapman BE, and this has been loaded up onto the course website, and it's a Chapman BE it's a compressed tar file. So you just have to compress it, and now you'll have uncompress it, and you'll have the whole directory structure of the package. And I've got, just to kind of show you, okay, here I am. I'm in the Chapman BE. So if we go down to, this is actually a top level where I have things like the setup.py that I'm going to use to build the package. If I go down to Chapman BE, this is where my code actually is. So you see I have my init function. I have a couple of modules, strings.py, my favorite functions, and then I have a couple of directories, hello and my class, that act as subdirectories. If I go to my class, again, it's a subpackage, so I need to have an init function file, so this directory looks like a package, and then I have a module file. So I can import my Chapman BE. This tells me what I have defined. I have an all variable doc file loader, and I have this one module that's available when I imported Chapman BE. And if I come over here, I'll show you my init.py. So in this, I explicitly import that module when I import the package. And this dot syntax is necessary for intra-package referencing. And while in the module, you see that there's also let me go up a directory. There's also the strings.py module. Because I didn't import it in my init.py folder, you see that it's not available here when I import just the package. Okay, so I can now call that function, print Chapman BE, my favorite functions, reverse my name, gives that output. I can get help on the package. Let's see, let me go up here. I changed the package name, so let me just evaluate this. Make sure that's in my namespace. Okay, here's my help. Tells me where it's located. I've actually installed it into my Anaconda environment. Tells me my data, etc. Okay, here I can get help on a specific function. I've imported it with a rename. Okay, I've included here a link to the guide on packaging of what the current standards are for creating and installing packages. Okay. So oftentimes, language Python, fans refer to Python as having batteries included. And this means that there's a large number of modules, packages, libraries that provide a lot of functionality that you don't need to recreate. And so there's a number of them that ship that are part of the core Python language, but aren't automatically available at runtime, that you have to explicitly import them. We'll also review some third-party modules. Okay, so there are a lot of modules. So if you look at the Python documentation, you'll see a list of all the packages that ship with Python. So there are tools for archiving and writing to a file. There's tools for parsing XML and HTML, for working with HTTP, FTP email protocols. There's file processing, working with your operating system to identify files, copy them, move them around, interacting with your operating system, creating and running regular expressions, interfacing with databases, mathematics, and a lot more. So some that will be important that we will be using throughout the class is Pickle. So Pickle is an absurdly simple way of writing Python objects to disk. We'll always be using cpickle instead of Pickle because it's a C and thus faster implementation of Pickle. You can pickle almost any Python object, and it's extremely convenient from a Python programming point of view, but it is a Python specific format, so it's not a way that you can write out something and share it with a different programming language. So here I'm just showing that I can create, in this case, a dictionary representing like a cancer history, and then all I have to do is I open a file and I dump my object out to that file with the cpickle.dump, and then I can load it back up, print out the data, and I have all my data back. Sys provides functions and variables that are closely associated with the Python interpreter and how it is interacting with the computer. So things like your Python path. The sys.path is the list of directories that Python is looking for modules and packages. argv is for command line arguments. Standard error, standard in, standard out are input and output definitions. OS is a package for working with the operating system. We'll use this a lot for creating path names, file names, splitting path and file names up. You can execute system commands through that. So here I've imported OS and I'm testing whether if Chapman B exists, asking whether that is a directory, which it is, asking if it's a file, which it's not. Okay, so glob provides a Unix-style path name expansion for wildcard matching. So I can import glob and I can look in my directory and get a list of all the files that end with .ipynb. So these are my modules. shutils, so that's like shell utils, high-level functions for copying, deleting, modifying files on your system. The RE is the regular expression package module, and it provides Perl-style regular expressions. Okay, those are packages that always ship with Python. They're part of a Python distribution. But even there, it's not broad enough for all the applications we might think of. And so the real power of Python comes from the multitude of third-party packages that are available. And many of these, but not all, are listed in the Python package index, PyPy. Used to be called the Cheese Shop, and there's a link to that there. And these packages can be installed directly over the web with either Easy Install or the newer preferred version, pip. I should say that not all packages work with pip, so sometimes you have to fall back and use Easy Install. So some important third-party packages include NumPy, which we've been using, Matplotlib, which is the standard but not the only graphics plotting package available for Python, and SciPy, which provides numerous packages for scientific computing. NetworkX will allow us to have graph or network representations. We'll learn about NetworkX. Pandas is a convenient data analysis, and we'll be learning Pandas pretty soon. PyDicom, read and write and modify DICOM files. We use this on the very first day. Scikit-learn is a machine learning package, and we'll work with this also.